Hello again. In this video, we want to look at SI prefixes. Okay, so these are rather large or rather small, perhaps, numbers, which we use as a nice, neat, concise shorthand to basically save ink and time. Okay, so I'd like to start off with the largest one I want to consider here. 10 to the power 18. So what does that mean? Well, the symbol for that is capital E. It's known as exa, and it represents 1 followed by 18 zeros, like so, separated by commas, each group of 3. Okay, there's 4 groups, 5 groups, 6 groups of 3. That is what 10 to the power 18 looks like. That would look really nice in your bank account, no doubt. Okay, we can move on down by divide by 1,000 or a factor of 10 to the power 3. So essentially we're coming down in the index, the power here, by a factor of 3. So the one below here is going to be 10 to the 12, of course. So 10 to the 15, we have a capital P, and this one is known as peta. And that's going to be 1 followed by clearly 15 zeros. Okay, try to get them as quickly as I can. There we are, so 15 zeros. We move down, as I said, 10 to the power 12. A lot of people know this as Terra, capital T, and that's 1 followed by 12 zeros, like so. Okay, 10 to the power 9, probably even more familiar to more people. Capital G, our very best G, Control Z that. There we go, that's a bit better. G for giga. So you've heard of things like gigahertz for frequency, possibly Bluetooth or something, and you may have also heard of gigawatts in a power station, etc. Okay, so it's giga, and well, according to the index number here, 9, so it's 1 followed by 9 zeros. Also known as 1 billion, in the UK at least anyway. Okay, 10 to the power 6. We have capital M because this is mega. Okay, and it's just 1 followed by those 6 zeros, predictably. 10 to the 3. We have a lowercase k, kilo. Kilograms comes to mind, etc. 1,000 grams. That's just 1 followed by 3 zeros. Okay. How about, well, I'm subtracting 3 from the power all the time, so I've gone 18, 15, 12, 9, 6, 3. Why don't we then do 0? 10 to the power 0. Well, anything to the power 0, apart from 0 itself, of course, which we can't really define, but anything else to the power 0 is always 1. And this is given the name unity, and it is just 1 followed by 0 zeros, as it says here. Okay, so 1 followed by no zeros, which is just a 1 on its own. Okay, it's good. Now we start getting to the smaller numbers. So 10 to the minus 3. This is little m. It's known as milli. Okay, it's known as milli, and it's, well, there are 3 zeros here, but one of them leads the decimal point, so there's 3 zeros and the 1. That is 1 milli. Okay, this is very important that you remember there are only 2 zeros after the point. So where's the third one? Well, it's the one before the point. Okay, then we can move on and we can go for 10 to the minus 6. Okay, a lot of you know this as micro, micro. 6 zeros here. There's 1, hit the point, do the other 5. 1, 2, 3, 4, 5, and then put a 1 in. Okay, progress further. 10 to the minus 9. There's a little n. Many of you, again, will know this as nano. So a 0 is one of them, followed by the other 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, and then the 1. 10 to the minus 12. We know as pico, little p, pico in here. Okay, so a 0 followed by 11, 6, 7, 8, 9, 10, 11 zeros and a 1. A couple more to go in this table. 10 to the minus 15. There's little f, not used by many people, femto. And that's 0 followed by 14 zeros and a 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and a 1. That's what femto looks like, really small. And smaller still, last one I want to put in the table, 10 to the minus 18, just to balance up the 10 to the plus 18 at the top there. This is a little a, and this is known as atto. And predictably, there are 18 zeros. First one is preceding the decimal point. The other 17 are after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then the 1. Okay, so extremely, extremely small. I just want to go over here and remind you about one or two things regarding these types of numbers or representation. So a reminder, if we say 10 to the power 6, we can also express that as 1 over 10 to the minus 6. So you can bring the whole thing down here upstairs as long as you change the sign. So effectively, this is the same as bringing it all upstairs and change the sign from minus to plus. And it's just, oh, it's certainly not 3. What am I doing? It's a 6. 10 to the 6 equals 1 over 10 to the minus 6 equals 10 to the plus 6, which of course is 10 to the 6, which is 1,000,000 because it's there in our table. Okay. Conversely, I could swap these two guys around here and I can say 10 to the minus 6 is the same as 1 over 10 to the plus 6. And 10 to the minus 6 is this thing here. So it's just 0.5 zeros, 1. Okay. You may also see these SI prefixes mixed with numbers which are not just standard 1 or 10 or anything. So, for example, if we had a number like 1,250,000, perhaps your bank balance, that would be expressed as, well, it's a rather large number. Perhaps we can use some standard form here and express this as a number between 1 and 10 times 10 to the something or other. Well, what's the something or other? Well, let me just put the decimal point in where it is. There it is. If I want to express it in standard form, I'm going to move this back 1, 2, 3, 4, 5, 6. If I put the decimal there, I'll have 1.25, which is good. 1.25 1.25 times 10 to the power, so I've moved the point left, so we're going to have a positive power. How many places have I moved? That's going to be the power. Okay, 1, 2, 3, 4, 5, 6. 1.25 times 10 to the 6. So we've utilized this factor here. Okay, and it's mega. That could have been perhaps watts. So you may have had, go back to yellow, you've had 1250, I'll put a comma in there, perhaps it was power, so it was watts. You may not want to put the times 10 to the 6 because lots of people know 10 to the 6 over here as mega. So you would then write 1.25 space capital M W, 1.25 megawatts. These two are the same thing, or they certainly will be if I stick a W there. Okay, and lastly for the smaller numbers, so we may have, for example, 0.00365 as a number. That is going to be exactly the same as, well, we try to express it in as a number between 1 and 10 in standard form. So I'm going to find out where the point is at the moment. It's here, and move it over 1, 2, 3. That will do, because that gives 3.65. 3.65 times 10 to the what? Well, I'm moving the point to the right, and when you move the point to the right, the power is going to be negative. I moved it 3 places, so that's going to be -3. And if there are watts or volts involved, then you put the sign, the SI unit in at the end. Okay, so hopefully that's been a good introduction to SI prefixes for you. Extremely useful for all scientists and engineers. So I do recommend certainly that you learn this group off by heart, because that group will be used in the vast majority of cases. Okay, hopefully that's been useful for you, and thanks for watching. See you in the next video.